All right, I'm going to walk through how to take the Laplace of a derivative. So first thing we need to do is define what the Laplace of a function would be. So the Laplace of a little function, x of t, we use a capital X and it's of s. Why is that? Well, I'm going to do my best here. So this is a definite integral that I'm integrating with respect to time. Typically, when we do a definite integral, we get a number out. For example, say I had the integral from 0 to 2 of x squared dx. Well, that's a number. It doesn't have any x's in it. So the variable that we're integrating with respect to, what we say is that it gets integrated out. So this thing right here has t's in it, but it also has s's in it. So when we integrate this thing, we're going to get a new function that has s's but no t's. So that's why it's a function of s. Just roll with it. All right, so if I was taking the Laplace of y of t, I would just call it capital Y of s. I don't know what it is, but we need to call it something, so that's what we call it. So to take the Laplace of a derivative, well, what am I going to do? I'm going to plug it into our formula. It's the integral from 0 to infinity of x prime of t times e to the negative st dt. Ooh, integral of t squared e to the negative st. You should know how to do that. I use dir and int. I use integration by parts. So what I'm going to do here in trying to take the Laplace transform of x prime of t is we're going to use the dir and int, but I'm going to sort of flip it around. I'm going to put this on the int side and this on the dir side. And then if you've done any math with me, you know how to do escape method. So my dir side is this thing, e to the negative st, which I get ba-bam, ba-bam, little bit of chain rule. And my int side is x prime. What's x prime int to? It ints to x. So what do I get? I get this product minus that integral. So this diagonal one gives me this row. And then I get minus, and then I get this other negative here. So I get a double negative. So I get plus, and then I get s e to the negative st dt. So what I'm getting is s e to the negative st dt times x of t dt. So watch, I'm going to just reorder some things here and evaluate some of them. This piece right here is totally evaluatable. E to the negative st times x of t, evaluated from t equals 0 to t equals infinity. We'll get to that in the next line. And then what I'm going to do here is pop the s out front. I can do that because this is an integral with respect to time, and s doesn't have any t's in it. So it just pops out front, like any old coefficient would. So I get s times the integral this should have a 0 to infinity of x of t times e to the negative st dt. Now I'm going to zoom out, and I want you to see that this right here is exactly what we have right there, if I had written my bounds correctly. But notice, bam, that's x. That's capital X. That is just the Laplace transform of this little x right here. That may be confusing, but it works out really nicely for us. So what do? I just take this and I replace it with an x right here. And I'm not writing x of s, I'm just writing x because it's a little bit easier. And it's always implied, and you'll see that as we do this, that x is always a function of s. So that piece, quite easy actually. I just get plus s times x. Now I got to do this mess quickly. T equals infinity, plugged into this. It is exponential decay right here. So I get exponential decay times x. Bam, goes to 0. There's a small asterisk. I have to make some qualifiers about x for that, but we're just going to say that goes to 0. And now I got to plug in t equals 0 to each of these. So what do I get? I get e to the negative st, evaluated at 0. Bam, that's 0. And then I get x evaluated at 0. That is x of 0. Wait, those are the initial conditions, or part of the initial conditions. I might have said to you already that the initial conditions get embedded into the Laplace transform. Bam, that's how right there. So what do I get when I simplify all this stuff? Remember, there's a plus right there. I get s times capital X minus x of 0. And that's the Laplace transform of x prime. Coming up next, Laplace transform of x double prime.